Hello friends, computing relative feature importance. In this video we will learn about Adaboost Regressor. So when we are working with a dataset that contains n-dimensional data points, we have to understand that not all features are equally important. If we have this information, we can use it to reduce the dimensions. So if we are removing this dimension, if we are removing these redundant dimensions, then it will increase our performance. So for that we will be using Adaboost Regressor. Adaboost Regressor are used to compute feature importance. So what are these regressor? Adaboost, short for adaptive boosting. It is an algorithm that's frequently used in conjunction with other machine learning algorithms to improve their performance. In Adaboost, the training data points are drawn from a distribution to train the current classifier. This distribution is updated iteratively so that the subsequent classifiers get to focus on the more difficult data points. The difficult data points are the ones that are misclassified. This can be done by updating the distribution at each step. This will make the data points that were previously misclassified more likely to come up in the next sample dataset that's used for training. So these classifiers are then cascaded and the decision is taken through weighted majority voting. So this was the basic concept of Adaboost Regressor. So let's see the program for how to use that regressor. Okay, let's see the program for Adaboost Regressor. First you have to import few modules. So these modules are your NumPy, Matplotlib and sklearn, scikit-learn module. So we are imported these modules. Next we have to load data. So in that we are loading inbuilt data set from scikit-learn module. So we are using datasets module and the function load Boston. So we are loading Boston data from the datasets and this is your housing data variable. Next we are shuffling our data, so we are using shuffle function for that, and x and y. So x is representing your data and y is representing your target. So this function is returning a tuple in the form of data and target. Next step is to split our data into training and testing dataset using train test split function of cross validation module. Next part is your Adaboost Regressor model part. In that we are using Adaboost Regressor and we are passing here decision tree regressor whose max depth is 4. So max depth is representing your height of the tree, and these are your n estimators and random state. So these are your parameters for that regressor. So it is returning a regressor and then we are using fit function on training data. Next part, we have to evaluate performance of Adaboost Regressor. So we are evaluating mean squared error and explained variance score. So what is the meaning of these two parameters? So mean squared error is a measure of the quality of an estimator and it is always non-negative and values closer to 0 are more better. Okay, and your explained variance is your proportion to which a mathematical model accounts for the variation, or you can say dispersion of a given data set. So these are the two parameters, you have evaluated them. Next part is extracting your feature importance, which is your important task here. So you are using regressor dot feature importance. Now this is very important. Since this regressor is your Adaboost regressor, so we can find feature importance from with the help of that regressor. And housing data, this is your feature name. So we are taking feature names in feature names variable. So this is your feature importance and feature names. Next we are normalizing our importance values. So we are applying that formula and normalizing them. Next we have to sort our values and flip them. So for sorting we are using arg sort function of numpy module and flip UD function of numpy module for flipping purpose. So flip UD function is used for flipping up down. UD is denoting your up down. So up row will come to the down row and down row will flip to the up row. So this is your index sorted. Then we are arranging our X ticks. Ticks is representing your X axis labels. I am saying X axis labels. This is your ticks. Next we are plotting our bar graph. So for that we are using PLT, that is your pyplot module of matplotlib, and we are using function bar because we are plotting our bar graph for that. So in that bar the X axis will be POS, that is your sorted data, and next your Y is feature importance. X text is representing your name given to the X axis, X labels, so these will be your pause, and Y label is your relative importance, and your title of the bar graph will be your feature importance using Adaboost Regressor. Next you are displaying your bar graph using show function, and X text, that is your labels to each X axis. Okay, so that was your program, and we have mainly used here Adaboost Regressor and feature importance function of that regressor. So next run that program. So this is your bar graph. In that bar graph these are your X labels, and these are showing different features. So the maximum feature importance is of L state. So this L state is that feature which have maximum feature importance. So that feature is very important, and Zn is having very minimum feature importance. So this will have very less important. This is very less important feature. So using Adaboost Regressor we can determine our feature importance and can find that how much important your feature is. So in this way you can use Adaboost Regressor on your regressor. So that's it. Thank you.